Homework number 16. For these three questions, you're asked to graph each equation on the axes below. The quickest way to graph a linear equation is to start at the y-intercept point. That's a point on the y-axis. So for us, our y-intercept is -2, which would be here. The next thing to do is to use this slope ratio to help you move to more points. And we move by recognizing that the numerator is the change in the y value, and the denominator is the change in the x value. Some people like to call this a rise and a run. You'll notice there's a negative sign here, so I'm going to give it to the 1. The change in y is -1. The change in x is +3. Down 1, right 3. Now we could have also given that negative sign to the 3, which means we would have went up 1 and left 3. Doesn't matter which one gets the sign, but you can only use the negative sign once. You were instructed to draw arrows on both ends and label the line. Let's try number 2. The y-intercept is +6. The slope can't be seen, so that makes them invisible ones. -1 on the y-axis, +1 on the x. And we can continue this pattern until we reach the edge of the grid. Be sure to put arrows on both ends and label your line. Last equation has no y-intercept, so that means it's the origin. Now we can follow our slope by making it a fraction by putting a 1 underneath. The change in y is 4, the change in x is 1. I can't make any more points going up, so I'm going to make some points going in the other direction. From the origin, instead of a +4, I'm going to go -4. And instead of a +1, I'm going to go a -1. Make sure you draw some arrows and label your line. Next section. Find the rate of change and show your work. In this problem, the x is on the wrong side. So in order to move it over, I use an inverse operation, which results in a sentence that looks like this. The rate of change is always the coefficient of x. So the rate of change is -5. For the next question, I have 2 points. So I'm going to use my y2 minus y1 over x2 minus x1 formula. Placing my digits in the correct places, I can now compute. Don't forget, subtracting a negative is really adding a positive. So this results in 1/8. Over here, I'm going to use the mental math pattern. And over here, I'll do the same. Remember, when you find your patterns, they go into the fraction in this order: the change in y over the change in x, or delta y over delta x. It looks like this is increasing by 5, and this is increasing by 3. That makes my rate of change 5/3. The next question is a graph. We could find our change in y by making a little slope triangle like this, between any 2 points we like. You'll notice the change in y is always 1 unit, and the change in x is always 2 units. Question number 8 is not in slope-intercept form, so I need to use my inverse operations in order to isolate my letter y. Now you notice on this side it doesn't matter which comes first, the constant or the variable term. But you must always isolate y by dividing by its coefficient if necessary. Sometimes it's an integer value, and sometimes it's not. And we leave it as a fraction if it's not an integer. Oops. Now it's asking me to find the rate of change. That's this number here. Last one, I'm going to use my y2 minus y1 divided by x2 minus x1 formula, giving me negative 8 over positive 2, which reduces to negative 4. This next section asks you which one has the greatest rate of change. Function A, which has a rate of change of 3 over 1, also known as just 3. Function B has a change in y of 1 and a change in x of 5, so its rate of change is 1/5. And then the last one, the rate of change is the coefficient of x, which has a rate of change of 4. That means C is the winner. Question 11. Find the rate of change for the following data. Set up your subtraction fraction. Label your points if necessary, and put them into the y2 minus y1 divided by x2 minus x1 formula. 4 minus 4 over 9 minus 3 gives us 0 over 6. A 0 in the numerator means you have a slope of 0. For question number 12, I can't identify the rate of change unless the sentence is in y equals mx plus b form. So I'm going to need to divide by my coefficient here to isolate the letter y. And once I do, I get a rate of change of negative 2. Question number 13 asks you, which one of the following is not written in slope-intercept form? Well, in order to be written in slope-intercept form, your equation has to be isolated for y, which all 4 of these are. But look carefully at their x values. You're allowed to have an x value with a coefficient to the left, like this. You're even allowed to have it in the denominator. But x is not allowed to be in the denominator. And if it's in the denominator, it's not written in slope-intercept form. So that means that the answer to this question is letter D. Number 14, find the solution by using inverse operations. Don't forget to write your inverse operation equally on both the left and right side of your equation. Now you can solve your problem in a different order than I'm solving mine, but we'll always get the same final answer. For example, with this question, we might both distribute first. But then you may decide to use an inverse operation like adding 5 to both sides, and I decide to use the combining like terms property, which allows me to shrink up this left-hand side here. Oops, I forgot my x. And then maybe you decide that you want to subtract 0.3x, and maybe I decide that I want to subtract 0.4x from both sides. It doesn't matter. Eventually we'll get the same final answer. And that is that x is equal to 10.